Hey guys, today's lesson is going to be about rational functions. So let's look at what a rational function is. A rational function is just the quotient of two polynomials. So if you have a polynomial on top of another polynomial, that's called a rational function. Now there can be any polynomial except q, the bottom polynomial, cannot be zero, which if you think about it makes sense because, well, we can't divide by zero. So let's look and see what's going on with these guys. So how to graph them? First, we need to simplify the thing. So the first step, I want to see every single time, factor those things. If they, if the trinomial, factor the trinomial, use grouping, AC method, whatever, just factor it. And then, whatever cancels out, top and bottom, that'll cancel out. Then you're going to find the x-intercepts by setting the numerator equal to 0. We need the y value to be 0 to find the x-intercept, and if we, have 0, let's look at the function. If we have 0 equals this, we multiply both sides by q of x, so it doesn't even matter what happens with that because 0 times anything is still going to be 0. That's why you just need the numerator to be equal to 0. We also need the vertical asymptotes. We get those by setting the denominator equal to 0. Okay, so we're going to have a vertical asymptote and a horizontal asymptote. Now, we may not have a horizontal asymptote. It depends on the degree of the numerator and the degree of the denominator, how they're related to each other. So here's the different cases. If the degree of the numerator, p, is greater than the degree of the denominator, there is no horizontal asymptote. We're going to abbreviate that ha. Vertical asymptote, we're going to abbreviate ba. Now, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. So if our numerator is, let's say, a square function, quadratic, and our denominator is a cubic or even a quintic or anything above a cubic, then the horizontal asymptote will be y equals 0. Now let's say the degree of the numerator and denominator are equal. Then you'll have another horizontal asymptote of y equals the quotient of those leading coefficients. So if we have, let's say, might help by writing not white, ax to the n plus, who cares what else, over bx to the n, that b equals to both n, plus, who cares what else, then it's going to be a over b, the leading coefficients. So we divide those leading coefficients. Now there's one more condition that we don't get to in this class, but I want to just mention it here. We will talk about it next year in Algebra 3 or dual enrollment, either one. And that's if the degree of the numerator is exactly 1 more than the degree of the denominator. Then we have what is called an oblique or slant asymptote. And the oblique asymptote is found by using long division and ignore the remainder. We're actually going to see an example of that in a few minutes. So these are your rules. Remember them. The last step is to identify any holes that might occur in your graph. Now, a hole happens whenever your numerator and your denominator have a common factor. When those common factors cancel out, it produces a hole in the graph. It could also produce a vertical asymptote, so it'll technically just be, vertical asymptote. But depending on what the function looks like, you could just have a simple hole in your graph instead of an entire asymptote. You'll actually see what they look like because we're going to use Desmos to graph these mostly. You are going to identify the pertinent information. You're going to sketch them, but you're going to use Desmos to help you sketch them. If you don't know what Desmos is, if you're in this dual class and didn't use it, it's an online graphing calculator, And if you just type in Desmos, D-E-S-M-O-S into Google, you'll find it. Now, to find where that hole would occur, let me move my face out of the way. You set whatever that common factor is that canceled equal to 0. And then whatever you get, you substitute that x-coordinate into the simplified function. So we'll see examples of all these kind of things. So for now, just bear with me. So let's look at this example. My face is really in the way. Let me make myself smaller. That'll work. So we're going to graph each function and identify its key characteristics. So it wants the x-intercept, vertical asymptote, horizontal asymptote, hole, there may or may not be one, domain, and range. So I'm actually going to also add these the y-intercept. Those are easy enough to calculate. You just let x equal 0, so it'd be -4/4 to be -1. So plotting those points is going to help us graph these things. And of course, I'm going to come over here to where you'll be doing it, so you can actually see what it's going to look like on your screen. So again, we're going to have all this information. I might make it a little bit bigger so you can type it in there. But what I need to see is this thing factored. Now this one here, it doesn't factor. It's already simplified as much as it can be. So that's good. So let me get the x-intercept. To do that, you set your numerator equal to 0. I don't need to see that scratch work. You can do that on paper, or you can just do it in your head. X is going to be 4, right? X minus 4 equals 0. Add 4 to both sides, x equals 4. I don't need to see that work. And you can write it as an ordered pair. So we're going to put a text box in there. We said 4 is the x-intercept, so it's 4, 0. Now I also said I want the y-intercept. I'll have a little blank for you whenever I make your lessons. Y-int will look something like this. It'll probably be below the x-intercept. And that's going to be 0, -1. You can have at most one y-intercept. You can have as few as 0. You might not have any x-intercepts, you might not have any y-intercepts. You could have multiple x-intercepts, but at most one y-intercept. So if you have 2 y-intercepts, you did something wrong. Vertical asymptote. Remember, denominator equals 0. Again, I don't need to see that scratch work. X plus 4 equals 0. That means x equals -4. That is what I need you to write, the equation. Not just -4, but x equals -4. All right. So now let's look at the degrees of our numerator and denominator. That's a degree of 1, that's a degree of 1. That means our horizontal asymptote is going to be the quotient of those leading coefficients. We have this case right here. Y equals the quotient of those leading coefficients. Let's look at it. Well, that's 1x over 1x is 1. 1 over 1 is 1. So I have a horizontal asymptote at y equals 1. And again, it's going to capitalize that for you. That's fine. Don't worry about it. We couldn't factor it, so there's nothing that cancels. So there's no hole. So I'm going to put in A there. Do put in A or none or something like that, so I know that you didn't just accidentally skip it. The domain, well, that's everything except where I have a vertical asymptote. So, and you know what? Let's make sure we graph these before you do domain and range, because sometimes it might look a little weird. Let's sketch it. I can go ahead and plot these points and draw my asymptotes. That's what I'm going to do. And really, this is a bunch of point plotting. So I'm going to start with my asymptotes. X equals -4. Let's see, 1, 2, 3, 4. Hopefully I can count. I'll shift down. And again, I'm going to make these red so they stand out. I'm going to make them dashed. And I'm going to make them at least 4 points. 4 points works. I can even do 8 maybe. Let's see what 8 looks like. Yeah, I like 8. I'm going to do 8. long as I can see it, it's good enough. Now I have a horizontal asymptote at y equals 1. And let's see, does it format it the same? It does not. Red, 8 points, dashed. This is what I got so far. So my graph's going to be in either like something like this maybe, or maybe it's going to be in bottom and top, or you can actually figure this out looking at the end behavior, but we're just going to use decimals. We're going to take it easy. Go ahead and plot these 2 points, 0, -1. So I'm going to drag and drop that, 0, -1. Now, I'm just going to give you 6 dots. If you need more, copy, paste. There it is. I don't know how many you'll need because, well, some of them you'll need more than others. And then 4 zeros. So 1, 2, 3, 4. And move that around. Remember, shift lets you move it nice and gently. It doesn't have to be perfect, but I'm going to make it a little bit neater. We know what this side's going to look like. It looks something like this. Now to get this side over here, I don't know if it's going to be up here or down here. The way I had to do it back in high school, I had to take a point on the other each side of my asymptotes, my vertical asymptotes, and see whether they were above or below my other asymptotes. So this is at 1, 2, 3, 4. So if I go -5, that'll get me what's going on this side. So let's see. -5 minus 4 over -5 plus 4. So all I did is I plugged in -5 for x here. That's going to be -9 over -1, which is a +9. So that tells me, I can go ahead and pop that point. I plugged in -5, I got 9. So I'm going to put -5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you don't have to plot this point. I'm just doing it, so I already grabbed it, so I might as well. So now we can see about what this thing's going to look like. I'm going to scribble it. Something like that. Make it blue and nice and thick. 4 points of work. Yeah, it's good enough. Scribble again. It's going to look something like the curving somewhere. So that's about what it's going to look like. All right, so that's one way to do it. However, I'm going to let you take a shortcut. You're going to go to Google. You're going to go to Desmos. 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 Beautiful free math. Click it, or you click the calculator down below. Start graphing. We're just going to type in our equation. X minus 4 over x plus 4. So you can either start with the division. I just use the slash below the question mark and do x minus 4 on top, x plus 4 on the bottom, or you can use parentheses to group them, your choice. So yeah, it's pretty much what I have right here. That'll work. So if you want a couple points, you can just click on here and say, okay, it's about -8, 3. So I can pop that point. Or actually, I can't, can I? Maybe I can. 4, 5, 6, 7, 8, 3. So it should be up here. See, I'm going to go ahead and fix this one. Get a couple points in here so you can kind of sketch it nicely. Doesn't need to be perfect. Not terrible, though. I don't want it to be straight. And about like that'll work. There. Terrible graph, but that's what it's going to look like. Nice and curvy if you can. I can't. I suck at drawing, but that's okay. As long as I can see you know what you're doing, we're good to go. So now let's talk about the domain and range. So yeah, this thing's domain and range is looking like it's going to be like I thought earlier. The only points we don't have are this x is -4 and the y is 1. So again, make a text box for your domain. I need -infinity. Well, I go grab my infinity button again, insert, special character. I'm just gonna wiggle like this, make an infinity symbol or fish. And then what I'm gonna do is I'm gonna highlight that, Command C for me, copy, -infinity to -4 for my domain. See, it's split up right here. I'd never reached that point, -4. Union, -4 to infinity. That's my domain. And this, again, this interval notation for the domain, that's the main reason I wanted to use this lesson. I need to make sure y'all are all very familiar with that. It's one of the key parts for next year. Range is similar, -infinity to 1, breaks up right here. So we get closer and closer to this 1, but we never actually touch it. Union, 1 to infinity. And there we go. I use 4 points. We can actually check and see another point down here if we really want to. Let's see, -2. Looks like it's going to be -2, -3. Let's see how close I was on that. -2, -3. So it would look actually more like that. But you know what? Good enough. Get a couple points on either side and just plot them. Sketch it through there. Does not need to be perfect. All right. So that's the first one done. I'll do this one. Okay, I got a quadratic on top, so I can probably factor it. My class better be able to recognize that instantly as a difference of squares. Ms. Doyles, I don't know if you covered that or not. Hopefully you did. But this is x squared minus 1. Both of those are perfect squares. So we know that's going to factor as x minus 1 times x plus 1. And x minus 1 on the bottom. Now, if you suck at factoring for any reason whatsoever, go ahead. Oops, I didn't. I'm going to grab a calculator. I didn't open it yet. So if you suck at graphing, factoring, don't worry. The calculator can do it for you. All we need to do is solve this equation for 0 and work backwards. So it's a quadratic. So if we go to mode 5, 3, we can type that in. 1, 0, -1. And we see 1, -1 are our x values. So we know x equals 1, x equals -1. Once we have the solution to factor it, we just have to work backwards. We have to make it equal 0. So x minus 1 equals 0. That's one factor. Add 1 to both sides to get that away. X plus 1 is my other factor. So that's how I knew these would factor. Now, I do want to see this. I want you to write down this factored form. So that's the first thing I'm going to write over here. Grab myself a text box. X minus 1, x plus 1. And then I'm just going to do something like this. X minus 1. I'll center it a little bit. It doesn't have to be perfect at all. And then let's just scribble along through there. You could draw a straight line, but for some reason it wasn't cooperating, so I'm going to do that. Boom, perfect. Make it thicker if you really want to. That's good enough for me. But I do want to see this. So now, if I look, the same factor on the numerator and denominator, so that's going to cancel out. Remember what that means. It cancels, it makes a whole. So this simplifies to x plus 1, which everybody better be able to graph. That's a freaking linear equation there. But it's going to have a whole at x equals 1. So it'll be at, if x is 1, because we need to, well, let's just do work by hand. X minus 1 equals 0. That factor that canceled equals 0, so x is 1. I'm left with x plus 1, so 1 plus 1 is 2. That's my x coordinate, that's going to be my y coordinate. So I have a point 1, 2. All I do is I plug 1 in here. Now you could write the f of x over here, or the y equals, doesn't matter to me. I'm good enough like that. So while this technically would be a vertical asymptote if we just looked at the original, since it canceled, we don't have a vertical asymptote here. We have a hole instead. Nah. X-intercept. Well, that's whenever y is equal to 0, so an x-intercept at -1. So x plus 1 equals 0, x equals -1, y would be 0. I do want the y-intercept. Let's put it. If x is 0, y is 1, so I have 0, 1. Horizontal asymptote, let's see, what's the degree of the numerator? 1, what's the degree of the denominator? There ain't no denominator, so that makes it 0. Look at our rules. The degree of the numerator is greater than the degree of the denominator. There's no horizontal asymptote. Technically, there's an oblique asymptote, but we're not even going to see it because this thing is going to look like a line since, well, that's what x plus 1 looks like, a line. So another nah. Now let's graph this thing. Yes, you can use Desmos, but you really shouldn't need to. You should know what x plus 1 looks like. It's got a y-intercept of 1 and a slope of 1. It's going to be up 1, right 1 each time. So I'm going to plot my 0, 1, just like that. -1, 0, just like that. And I'm going to go ahead and stick a few of these on here. I have a hole at 1, 2. So at 1, 2, there's a hole. So here's what I'm going to do. I'll put a point there. Over there. And I'm going to change the fill color to white. That way I can see, oh, hey, there's a hole right there. So I don't want to put anything there. And you can keep on going if you really want to. I'm actually going to go all the way up to one side. Like that. That way I'll have a nice starting point. Just went up 1, right 1, up 1, right 1, and continue going up 1 and right 1 each time until we reach this point. Because again, our slope is 1 there. So now I can draw a straight line. That's handy. I missed. Let's try that again. Now it's gone through there. And something like that. I'm trying to line up with those these right here. That looks good. I'm again make that blue. I'll make them both arrows. Lines do go on forever. make it thicker. Let's make it 8. Now here's what I'm going to do. I'm going to take that point. That's my hole. I'm going to cut it and paste it. Now it's on top. I have a hole in my graph right there. I use Command X to cut. Make it a little thinner. Choose 4. There we go. Now I can see where this goes a little bit better. And there's my graph. Notice there's a hole right there. Hole at 1, 2. Now, my domain and my range is going to be everything except for where this hole is. See, there's no y value of 2, there's no x value of 1. So it's going to be basically the same looking thing as these. My domain, negative, infinity. Oops, I forgot. I'm just going to cheat right here and copy this whole thing. Delete this thing. Yeah, it takes a little bit of time. I'm going to change this -4, or my domain never hits 1. So x is never 1. See? No value for 1 on for my x. No value for 2 for my y's. I'm going to change these to 1s. I'll change these to 2s. And that's my domain and my range. Okay. That's what a hole looks like. Let's look at this one. All right. So I've got my numerator. My denominator needs to be factored. Again, you can use the AC shortcut. You can use the calculator. You can use the quadratic formula and work backwards. Whatever you need to do, just do it. You can even just look at it and be like, 20, that's going to be 4 and 5. Yep, they're both going to be positive. Okay, so it's going to factor like this. X plus 5, X plus 5, X plus 4, something like that. And I'm going to go back and delete some of those things. Make that small. Okay, so that's factored form. I need to see that. Again, if you don't know how to factor the dang thing, just grab your calculator, type this in, 1, 9, 20. -4 and -5 are your solutions. That means +4 and +5 make your factors. You just need to make those equal to 0. Desmos can also do that for you in a roundabout way. Type it in. X squared plus 9x plus 20. X, to get a squared, you do shift 6. Or you can just use these things over here, up to you. X squared plus 9x plus 20. And you can see -5, -4 are your solutions. That means x plus 5 and x plus 4 are going to be your factors. If we had a fraction, we'd have to take care of that. Just no fractions allowed, solve for 0. Let's see, I don't know if we'll even have any of those. Let me look real quick. Yeah, we might have one on this one. Yeah, we will. Okay, good. Okay, let me scribble a little line under there. Something like that. Okay, it disappeared, don't know why. That'll work. Good enough. Then these cancel. So I'm going to be left with 1 over x plus 4. And now you better know what that looks like, because guess what? That's a reciprocal Euler function. We're shifting the reciprocal function left 4 units. That's most, just use it if you need to. but things did cancel. So let's go ahead and take care of that. So that means I have a whole at, well, the factor was plus 5, so negative 5 is my whole. So the negative 5 is my x value. If I plug that in here, it's going to be 1 over negative 1, which is negative 1. I'll type that in the calculator so you can see what I'm talking about. 1 over negative 5 plus 4 is going to be negative 1. That's where my whole is. Okay. My intercept, let's see. That's the y-intercept here. So if I let 0 be x, then I have 1/4. So I have 0, 1/4. My x-intercept, I let y be 0, and there's not possible. 1 doesn't equal 0 in a vertical asymptote, negative 4. Even after we have a whole, we also have a vertical asymptote. You see that? Our simplified function does have a denominator still, so it still has a vertical asymptote there. So x equals negative 4, whatever makes that denominator equal to 0. And if we look, the degree of the numerator is 1 less than the degree of the denominator. This is 0 degrees for 1 degree. Let's look at our rules. Just remind ourselves, refer back to them, write them down on a separate sheet of paper so you can look back every time. If the degree is less, we have y equals 0. So now before I answer the domain and range, again, graph it, because sometimes weird stuff happens and you can't just look from this information and say what it is. So I'm going to plot my point. What point am I going to plot? Well, I've got a hole at negative 5, negative 1. Let me take care of that. Negative 5, negative 1. I've got a hole right here. So again, I'm going to change that to white. And later on, I'm going to cut and paste that. All right. So I shifted this left 4 units. So it was at negative 1, and then we went 1, 2, 3, 4. So that's where my basic point usually is. Let me draw my asymptotes. Oh, wait for negative 4. I'll make those red with 8 points and dashed. My horizontal asymptote is y equals 0. Red, 8 points and dashed. So you should know where this other point goes because we just did the reciprocal of other functions. It used to be a 1, 1, and we moved it left 4, so it's going to be 1, 2, 1, 2, 3, 4. It's going to be right here. We got a point there, and it's usually at a half 2. It's going to be right over here. This is usually at 2 1/2, so it's going to move left. Oh, I don't know why it went up there. Oh, go down. So it's going to go right there. I'll make an extra point. Usually down here. Oops. If you do that, you can either click undo or Command Z for me, Control Z probably for you. It'll show your keyboard shortcut. Now you have your nice little dot again. This one's going to be right here. And we know this because this is a reciprocal mother function. Just shifted to the left 4 units. Why are you up there? Go down. All right. And then I also have my y-intercept at 0, 1, 4. So I'm going to try and stick that on there, but it's kind of hard. That's good enough. And we can scribble it. And then we use Desmos to show you, hey, that's what it actually looks like. Yeah, I'm terrible. Be sure you realize that these are not going straight up and straight down. If it did, it wouldn't be a function, right? They're getting very slightly closer to the asymptotes. Make them 4 points so we can see them. Now put a little arrow on this side. That's good enough for me. Grab the other side. Something like this. And it's also not curving in like that. That's terrible. It's going ever so slightly closer and closer to this asymptote. But it is a little difficult to draw on here, so forgive me, I'm going to forgive you. So last step, I'm going to make sure my hole stays a hole. Not like that, that'll work. So I cut and pasted my hole again, so now it's on top, so it actually has a hole right there. If you're doing it on paper, you just use your eraser. For those of you that are terrible and use pen for math, well, don't. I will go ahead and stick this whole thing into Desmos though, so you can see what it looks like. I already have my numerator here. I mean, silly denominator. So if let's see, if I do this, no. Well, I can do this now. Yeah. What was on top? X plus 5? Yeah. So this is what I should have here. So let's look. At -5, it better have nothing. -5 is undefined. You see that? You can't really see it on here. For some reason, they don't visually show you the hole. But if you get right on, it says undefined. There's a hole there. And it has 0, 4. It also has -3, 1. You know, 1, 2, 3, 1. It has all these points on there. Have -3. Oh, here we go. Not counting my 1, silly. Has -4 over here somewhere. Or not. So yeah, it gets really close to the asymptote because, right, -4 is the asymptote. So you can see that dot as it's getting closer and closer, but those x-values are getting ever so slightly smaller towards -4. So it's not going straight up. And -3.5 should be 2. There it is. And there, yeah, you can see that. So you can use Desmos to help you out here. But on this one, you should be able to graph it. On this one, you should have been able to graph it. I will let you use Desmos though. Okay, for now. For now. Main thing is I want you to practice graphing these things and writing your domain and range and interval notation. which we didn't do here yet. Okay, the domain and range on this is going to be a little more interesting because not only do we have asymptotes, we also have a hole. So we have two numbers to not include in our domain and two numbers to not include in our range. So I can't include -4 or -5 in my domain. So let's see what that's going to look like. Let me grab one of these again. So first, we do left to right. -5 comes before -4, so I'm going to put -5 right there. Now I'm going to union that. From -5, I go all the way, not until infinity, but until -4. And then I union that, -4 to infinity. So that's what this domain is going to look like. We have everything to the left of -5, everything to the right of -4, and everything between -5 and -4. I forgot to put a comma. There. So that's how we would write the domain here when it has multiple intervals. Well, 2 is multiple, I guess, but if it has more than 2 intervals, we just stick another u in there. That's it. And make sure you use parentheses because we're not including those points. If you remember, brackets, that doesn't work. Brackets would actually include that -5 and that -4, and that's not what we want. So we don't want that. We need to make sure we have parentheses. Let's do that. Now I'm going to just change these numbers. Range are going from bottom to top. So the lowest point is right here at -1. So -1. That's -1 until we get to 0. And then from 0, we go all the way out to infinity. So from bottom until we get, so the graph goes on forever and ever and ever until we get to this -1 point. There's nothing there. So we skip over that, it goes up, up, up until we get to 0. Skip that, and then it goes up over here forever. That's our domain or our range on this one.